Right, we're doing another unscheduled workbench for that other project. Let's see, do I even have it up? I'll show it in a second. I want to make sure everything's set up. And chat's working. And we're listening to the Stardew Valley soundtrack. I feel like playing that game was just hanging out to the music was a big part of it. Alright. So we're having a lot of trouble with this reflect value. I've been trying to set a string on there. I think, well, I guess I was gonna try and reproduce it on play.golang, because none of my friends have been able to give me an answer of what's going on, why it's doing this, returning this error, which looks like when I start trying to write a value, it says that the value is unaddressable. Which, you know, we've gone through all the things. It's like, it's not a temporary value, you know, we assign it here. We've tried doing a reference to that value. But the thing is this was kind of a short-term fix to an actual field value on a struct. So I was thinking of jumping ahead and just getting some structs in that have some values. That way we can kind of work with the actual situation, and that might fix it as well. Because then the value is actually on a struct, which should be, as long as the struct is referenced, then just a copy of a value, then it should work. So the only thing it was is that we had this name, but I guess I could just use the name of the struct field. Okay. Let's get rid of this. We'll do a couple of structs that are similar-ish to those. Oh, Jesus. It's always something in VS Code. We'll do first car. These are just made up data structures. This one's basically the same thing in different order. And computer. All right. So now we'll do value points to empty interface. And then maybe fields can be the a map of the field name to a reflect value. That might be useful. So instead of new field, we'll create new object. And let's see. Oh, I guess we'll set up fields as well. And then, Lunin, what's up? Welcome back. Mirroring my yo. I'm good. Today I'm pretty good, I think. How are you? This music will help. Alright, so I'm gonna need to reflect on this value and then iterate over the fields. Fine, just fine. I mean, I understand. It's life these days. Number of fields, we iterate over that. We'll do field by index. Num field. On my channel page, my Spotify should show up, but I mostly listen to stuff on Spotify. Today is I mean, I used to go just by my normal playlist, and I'm glad to have added something new to it now, but you should see everything that I'm playing on my Spotify now playing, but eventually that's part of the project is I'll have it now playing in my menu bar, and that could be helpful. Both is an exercise for me to, you know, doing my weird automation stuff, and then also should be helpful for this stream. So you'd see it up here. Yeah, that's kind of where I'm at too. I'm dealing with this bug that my friends that know Go better than me are sort of stumped as well. So I was gonna create an isolated thing to reproduce it, but I'm just gonna try and do it a different way first and see if that helps. let's see. So this gets us field by index. Which returns a value. I think a value is not going to give us a name, is it? Returns the nested field. Returns the nested field. I'm looking at these. These look like the same thing. Maybe I want field. But I also wanted the name. I think names were kind of a separate thing. I've done this before. I should be looking at that code. Oh, right. I have to go through the type to get the name. Field gives us struct field on the type, and that gives us a name. All right, so then I can say fields name. Field by name, I believe, right? That's on the type. And that gives me the so here we'll actually do a couple new object foobar, create an instance of foobar with some values. First car, oh, but empty values is fine. Draw. I'll just pass that in. here we'll iterate over object fields. Field is a value, so we just do kind name. What? New object. Oh, we can just say it's always going to be a pointer to that object, so we'll say element, which then we can do armval type. All right, so it's can I put in a value? Ooh, look at that. Oh, and it does set it. Okay, this is awesome. Alright, so yeah, I guess part of it was that I was not actually referencing, before I was not referencing actual fields on a struct, and now that I am, they are addressable. And since this is ultimately what I'm trying to do, then this is fine. If I were to try and figure out why the other thing wasn't working, it would have been a waste of time. So now I have to think what next. Got these objects I can reflect strings and booleans. Yeah, I mean it helps. Oh, I know what we can do. Yeah, classic programming technique. Let's see, I need some kind of like console view because I have one, I need to have that eventually anyway, so let's see what kind of primitive I might use for that using this tview library. Maybe a text view. You'll see. Text view. Where is it putting the text into it? Oh, is text view a writer? I guess so. Well, that's nice. Let's see, so how would I flex view? I want a row at the bottom. Maybe I need nested flex things. Okay, yeah. This track is very sort of like Ocarina of Time. All right, so we're gonna have two flex. I guess we'll make one for columns. And another one for rows. And rows, let's see, set direction. Columns. Let's see, would this be maybe 3/4? I don't know if this text view has a box or what. Okay, it's a box, so I can. And I guess I want to write into it. All right. I guess I'll actually just call it log. And we have a go button. Let's pass the log in. I mean, I might as well just do something crazy and so. This should... Cool. Although, I don't know why it's only showing 3 lines. Oh, I guess because a new line... If we're always doing a new line, then... I won't try and fix that just yet. Alright, let's put some methods on these two things. We'll do one called Hello World. And it's just going to say hello. See. I guess we can do the same thing for methods. Yeah, I guess we would want to reflect if we want to call it. I guess we can just store the func. Store the func. Func with receiver as first argument. Now I forget if I actually need to. Let's see what's something I did this in. QRPC. API? Maybe export. Reflected function comes from value of function. Okay, so params is different. Value of receiver. Okay. Let's see, an export. There was an export. Export func interface. Okay. I think I know what to do now. But I need... Let's see. I guess reflective value. Params. Alright. Oh, I don't like func. Alright. This could do it. Let's see. Oh, no. Oh. Well, that was silly. Also, I don't know why that still works. let's see, it's the type that has access to the method, right? Oh boy. Type, method, returns method. Yeah, this is strange. Methods. Oh, I was doing new object before we even had this. Let's set it up early. It says it does not have any methods. Why? Why don't I believe it? Oh, who cares? Exported methods. The type's method is set. These are exported. We have an object, or an instance of a struct, reference to one, so we get the value of it, and we get that value, reflected value, and then we get the type of that reflected value, and we should have the struct, and it has some methods on it. Am I crazy? Maybe I can actually call. Hello world on this, right? Yeah. So no, maybe it's I need a value. I don't think so. Maybe I'll try it. Oh no, but this returns method returns a function value corresponding to the arguments called returns. Arguments to a call on the return function should not include a receiver. Okay, so this is function is different than the other method, and so I will have to call it differently. And I also don't have the name. Let's do this. We'll do M is our type method. And here we don't have to do call. Huh, it's still saying that they have no methods. Why would it say that? Let's figure this out. I think we have a name associated with that. Or a type. Okay. That is the name. Well, oh, did you? I solved one bug and came across another. Let's see. This is blowing my mind, though. basically saying the same thing. Flexu. What is up? Yeah, you're practicing your English now. Okay, so this is just like mind-blowing. It's showing me the type that we're looking at, but it says it has no methods. Which, like, there are methods here. Am I, like, not realizing something? Like, I could call this method even. Like, I'm not... Upgraded Go. I hope it's not like some stupid bug. Let me try and reproduce this. We'll just say print line. Log, where did I say? Oh. I've not seen the go-to video. I'd like to see that if you have a link. And in theory, I'm running 1.11 right now, but I'm really hoping it's not causing problems because it shouldn't. Like, it's not like they... Alright, so if we do flanked value of foobar, first we'll get the name. Foobar. How many methods does it have? 0. Now is it because we're talking about the pointer? It is. That is weird. The function pointer. I mean, let me see if this breaks other stuff. No, my friends have gone, but I haven't really heard anything yet, so I don't know what's new. Alright, let's see if this is different or breaks. Alright, so this is strange, so let's see. Construct type, yeah. This is so weird, but okay. I don't know, P type. Barbell element. I guess it would be the other way around, but we'll do V type and P type. Probably doesn't make sense to anybody. So num field needs to be on. Let's see, we want the one. This one is P type. This one is V type. This one is. Oh, P val, R val. All right, call field on a pointer value, field by name, Okay, that's true. I don't know if this is what we want. Maybe we do. Okay. I don't think it's scrolling, I guess. We can stop printing this out. Goodbye world and hello world. They're not the same. So, how is this happening? Got the name right. But for some reason the value is not. Oh, it's probably this whole thing. Okay. Let's take a look. Let's see, how long is this? I think we reached a milestone. I will go ahead and watch this.
Hi everyone! Last year, we started planning what to fix in Go 2. In our annual Go user survey, you all made your top 3 requests very clear. You want better package management, better error handling, and generics. I wanted to give you a short update about all 3 of those. But first, let me remind you how Go changes happen. The process begins with all of us using Go. Someone identifies a problem and writes it down, probably as an experience report. People suggest various solutions, which we all discuss, leading to a decision about which one to implement, evaluate, refine, and eventually ship. At any step, we might realize we made a mistake, backtrack, and try something different. The focus for last year was package management, meaning excellent support for working with programs built from many pieces written by many teams. Go 111 introduces the Go module, which is a group of related Go packages versioned as a unit. Modules record precise dependency requirements, leading to reproducible, verifiable builds. Modules also enable working outside GoPath, so that Go programmers can write code in any directory they like. But Go module support isn't done. In terms of the change cycle, it's around step 4. There's a solid design and initial implementation, but modules are still an opt-in feature. Experience with the next couple releases will help us revise the design and implementation. It will also take another year or 2 for the entire ecosystem to adjust to modules. At that point, GoPath and the old GoGet will have served us well in our first decade of Go. Go modules should serve us well for the next decade. Now, work on modules continues, but I also want to talk about error handling and generics. These are back on step 2. The problem is clear, and there are many possible solutions. More thought and community discussion is needed to decide which one to adopt. Recently, we published preliminary draft designs. We hope all of you will help us improve them and turn them into Go proposals. So let's talk error handling. Today, Go code often looks like this. One problem with this code is obvious. There's too much error checking boilerplate. But another problem is less obvious. There's not enough precise error reporting. A function should include relevant information about its parameters in the errors it returns, like os.open, including the name of the file that could not be opened. So really, the code should look more like this. But proper error reporting only adds to the boilerplate repetition, so most programmers don't bother. The basic idea we're exploring with error handling is to add a check expression to shorten error checks but keep them explicit. A new handle statement defines what to do when a check fails. Now it's easy to add precise error reporting in a single place. We also need to explore whether to define additional standard interfaces that error values might satisfy. But instead, let's talk about generics. This function filters repeated items from a channel of strings. The code is all about strings, and yet not about strings at all. What if the channel carries a different type? We have to copy and paste the code. What we'd all prefer is to make the channel element type a parameter that can vary, like this. One difficult question now is how to specify which types can stand in for T. In this case, the comparison v not equal next means that T must be comparable, like interstring, but not func or map. If this requirement is only inferred from the implementation, it's unclear to the caller of unique, and it's too easy to change requirements accidentally. Just like a function declares what kind of values it can be called with, it must also be able to declare what kinds of types it can be called with. In the current draft design, a contract defines the operations that types must support. For example, here is a contract named equal, declaring that 2 values of type T can be compared for equality. Unique can use the equal contract to declare which types T it accepts. A contract ensures that the implementation doesn't add new requirements, and it ensures that callers only provide types satisfying those requirements. This lets the implementation and the callers safely evolve independently. That's all I have time to show you today, but all the details are at golang.org/s as in short /go2designs. As I mentioned last year, Go 2 is not going to be a single release, so much as a sequence of releases, adding features as they are ready. I hope all of you will help us get them ready by writing experience reports and sending feedback about the designs. The webpage has more information about how to do that. Thanks very much, and have fun at GopherCon.
Sounds great. What are your opinions? It looks like I did this too late. But it's exciting. Obviously, everybody has been wanting generics, and so it's good to see progress on that front and starting to convey the actual problems and difficulties of actually implementing generics sanely. And I mean, it's really those two things, right? One is you're doing error checks all over the place, and oftentimes it's the same thing. If error, then return your normal return signature with the error. And so, you know, if you have big functions, you're doing that a lot. But so it's nice to kind of define that handler in one place. And then when you're doing top level stuff, I usually have a high level. Let's see, do I have an example in here? Maybe in Trello. Yeah, I usually have a fatal which for, you know, top level stuff, if it's not a reusable thing, you can have something like fatal that just checks if the error is not nil, and then either panic or log fatal. And you end up doing this all over the place. So it'd be nice to just say, you know, check, and you define that in one place. So it seems like a reasonable improvement. Especially if you do get complicated in your error reporting, because, you know, you'll want to, right, include all, you know, information that's relevant, or as much as is helpful. And if you have to do that all over the place, that is pretty crazy. So, and it's still not final, you know. This is the first I've heard of better error handling, and so, you know, it sounds like I'm happy that they're taking feedback from the community and working on these things now. I mean, they're very restrained in their process. They want things to be well thought out, and that just takes time, so. Right. Yep. I mean, I've worked with generics too, and they're great. And I usually found ways to work around them in Go. Like, it's never, to me, it always felt like a, you know, not as much of an annoyance as like kind of a fun problem to solve. Like, because there are ways. Most of the problems that you'd solve with generics, there are ways to do them in Go now. And it's not always code generation. So, like the one that I it actually took me a while to get used to is the way people do unmarshalling. So like, let's see if there's an example in here. Maybe I deleted it. Oh, in the mock, yeah, totally. So, you know, unmarshalizing or unserializing data from JSON or any kind of serialized format, that's the kind of thing where you'd expect the type that you get back to be parameterized, right? It's going to be like, you know, whatever your structure is for that data. And so the common idiom here is to instantiate an empty variable of that type and then pass it in by reference. And you basically get, you know, the same thing. It's just a little different. It's not returning that value. But this is a sort of way of doing kind of generics. It's different. And these things usually require some reflection to properly implement, and there's things you can't do inside the implementation of this that you would do with generics, but I'm just saying there's a number of patterns. An empty interface, yeah, the empty interface, taking an empty interface, returning an empty interface is something that I used to do as well, but then you'd have to do type assertions to get the actual type that you want. And so this way is much better because you're, from the user standpoint, you're not dealing with empty interfaces. And then in some cases, code generation is good. Like obviously not for like some helper things, but you know, in cases where you're probably going to be generating code anyway, like generating a client from a schema or something like that. You'd probably do code generation anyway. So I haven't felt like too constrained by not having generics. There's definitely times when I'd be like, oh, it'd be nice. And so it's good to know that eventually I'll have them, which is something that I always figured anyway. So I'm patient, but a lot of people aren't. All right, so what we have here, and some of the controls for this are not perfect, but what is this? Oh, yeah, and there's always going to be people doing experiments, which are great, you know, reference points for, you know, mainline Go. They can use this to learn from. So basically, I have a system where I can create some objects of arbitrary structs and methods, and then create instances of them. Let's go back to doing this. And put them in this list, and then I can kind of inspect them. And I can change their values. And their values are actually set in memory. So if I wanted to go here, Lindsay greet is an actual method, and I can call that method, and it uses last name. You know. So you know, I guess the point of this is to, you know, I'm going to be writing some systems that long-running interactive systems. QRPC, we'll get to that. So long-running interactive systems, and at some point being able to sort of compose systems. And so, you know, in a way, this is Unity, the game development tool I've been using, and you know, I like this paradigm of having an object hierarchy. And I did some work before on something called COM that kind of gave you something like this in Go, at least at an API level of having components. They also solve dependency injection and extension points and all this stuff. But so now I'm thinking, what if I had that, but having a hierarchy that represents the system that I'm working with, and I can go in and actually change values of that system in real time and perform actions on those, and they're just normal Go objects. And that combined with a system where I can kind of change code and have it rebuild and reload in real time gets you towards this paradigm that I had kind of thought about a couple years ago. I call it continuous programming, but it's where using your code and writing your code are sort of a continuous process, right? It's taking live coding and making it part of the experience of using. I mean, it's kind of like notebooks, right? In the way you can kind of interactively write some code, or using a REPL, but those are sort of very linear systems. Whereas here I'm thinking of actually building, you know, non-linear systems that are closer to real world systems that are doing actual multiple things and all this stuff. And so I think visualizing it and interacting with that those systems in a way with the values, like being able to edit the code is one thing that changes the structure of the system. Then being able to go in and change the values in that system, that's what this is kind of approaching. So, you know, being able to almost interact, you know, it's not quite a REPL. You know, in Twisted Python was the first time I saw a system where you could telnet into a daemon process and basically have a REPL into it. And it's, you know, obviously great for debugging, and it's also kind of like running a REPL the way people would doing, like, I think Rails popularized the interactive REPL in the environment of your application, so you can kind of debug and play around with your model and stuff like that. But it's, you know, that's working with your development database, or, you know, it's sort of a because applications are more, web applications are more stateless. So in this situation, an application that's more stateful that you can interact with. And so it's not quite a REPL, but you can still go in and kind of inspect values and change values and call methods on objects. And so that's kind of the approach here. The idea eventually with QRPC is that we can kind of generalize this to not be about Go objects and just be about objects in the QRPC, you know, bus system. So then it becomes a little bit more like dbus, and I can these objects might be backed by Go objects or JavaScript objects or Ruby objects, and they're all running in real time, and I can interact with them all in the same way. So eventually QRPC will come into this, but kind of building up these pieces. So this kind of proves the concept, which is good. I only have 30 minutes left. And one idea is to actually wrap this up so you can SSH into the process, which really depends on T-cell and whether or not it is hard-coded to use standard out, which would be really frustrating. I know a lot of these libraries do. Let's see, T-view, T-cell. It says it's based on T-cell. There we go. So we'll have to look in here and see. I guess we can look at the Go docs for it. Let's see how we would normally use it and set it up. Oh, I forgot, this doesn't ever have any code examples. So let's say boxes. So T-cell, new screen. All right, let's check this out. So it'll do this. All right, let's say we didn't have that. What's a new console screen? This is a stub, so console Unix, no, console stub. I guess it's just assuming that. Okay, so this, if you're on a Unix system, you're always gonna have term info, I guess. It's their assumption. And they do have in and out here specified by pointer, but I haven't seen where they actually set that up. Actually, I guess out. T-screen Linux. Term I own it. T-screen in it. So unfortunately, they make these internal things and they don't have any way that I can tell to actually set those, but we would need to do that if we wanted to send this stuff over SSH. I think it's ridiculous that, oh, sorry, you're taking off. All right, well, maybe I already missed you, but later. Yeah, I might have to do some kind of patch so that I can set these. I guess also signals is kind of a big deal. So these systems just aren't really made for T-screen. Well, actually, it's great because it looks like I can just create a new screen interface. So I could probably just copy all of this and then create a version that works over SSH. That might be the next step, because the point is not to run a program to get this, but to actually SSH into an existing program. But I'm trying to think of obvious things that this would need next. Support for more types. Right, we could do strings and bullets, but you know, all the numerics. Nested structs. Lists. Or, you know, slices. What else is there? Channels, maybe? And then argument support for methods. So right now these are methods that take no arguments. So I imagine if you tried to run an argument, run a method that takes an argument, we would pop up a form with all the arguments that you can fill in. The use case, I mean, I think this is mostly used for inspection and modifying values more than it is necessarily performing actions. And when you do perform actions, they would be high-level actions that don't necessarily, I'm assuming, don't necessarily take a lot of complicated, you know, take a variable from this type of thing, and you can just do, you know, some high-level input, or at least kind of debugging. Trying things. We'll see how much use we can get out of it, but I mean, we could also, I mean, there's a possibility of a sort of like an XPath query system where you can actually reference values from other objects in the system by, you know, kind of hierarchically saying something like, you know, in a field you would say $, maybe, or maybe it's just, you know, Baz Quooks, and then last name, and then maybe you can use those values in here interactively, and that would work. So but this should be driven from actual use cases. So now that we have a proof of concept, I should be trying to use it in other systems, which probably prioritizes the SSH interface. And more types. And of course this wraps up that T-cell stuff, so I need to start looking at how, not T-cell, but the T-view library works. Because if we can't change the screen, that would be location set. See, of course, this dumb library doesn't let you change the screen, which seems ridiculous. Oh, where does it get its screen then? Yeah, fuck this. Fuck this. I mean, I guess I should see what people are into. I guess this is a proposal. I don't know what the feature request. Documentations, your feedback, questions. Sam's band. That's awesome. This is in Stardew Valley. Alright, so we'll see how this goes. And in the meantime, I will get started on creating a project to get T-Cell to work over SSH. So let's get that started. So what is a good, like, hello world here? What are these views? What the hell? This is doing what T-Views is doing. It's crazy. 3 years ago. Weird. Whatever. Demos. Yeah, let's do something with the mouse because that's something I'd like to have working eventually, and you can do that over SSH, I believe. How is that sent over SSH? No, I don't want to use Hex Windows. Oh, right. It's just part of standard in. It's a byte sequence. Yeah, I forgot. I already looked this up before. So... or box drawing. I don't know, let's try it. This is cool. And it's all just standard IO. So yeah, it'd be pretty dope. Like, because it's just standard IO, it works over SSH. So now let's see, I have 10 minutes left, so we can try and let's see, this is still pretty complicated for Something really simple. I just want like the simplest hello world. Must include T cell. Oh God. Alright, I guess we have to figure it out ourselves. So what are we supposed to do? What does this app do? Okay, so we got a new screen. We do style, S, screen, enable mouse, set style, clear. Let's see, drawbox. What does drawbox do? This fills it with a rune, or what? Alright, let's rip this up and just do pull event. I should be able to. Let's see. Key escaped. Key control L. Event mouse. Draw select. We're not doing any selection. I don't know what the hell that is. For now, we'll get rid of that. I guess width and height we'll keep around. And ST. Draw select, we're not going to do. Draw box, and emit string is fine. Let's see if this compiles. BSTR. Oh, escape count. Why don't we just do it once? LKS, what the fuck is that? Up, declared and not used. All right, and I don't think anything happens with resizing this. I guess it redraws it, and that's fine. I don't know what that R is in the corner. Oh, I guess it's a saying that we resized. And it doesn't like clear it, so. All right, so this is a little bit simpler of a program that we can try and get running over SSH. I mean, next time. I'm actually gonna quit early so that I can do a recap summary video for YouTube. So I'll be back actually in an hour, and I'll be working on Indie Game Legend. And then later today, I'll be working on some other Go stuff. What is it? Well, actually not Go stuff. JXA, JavaScript, scripting. Creating a new menu item using JavaScript. Good to see you. Good to see you up. So I'm gonna take off and have lunch, but maybe I'll see you in a bit.